Hi guys, Alex here at Network A1A, and welcome to part 2 of the CCNA lab series. We're carrying on from the previous lab in which we implemented PPP CHAP between router 1, router 3, and PAP between router 1 and router 2. And then we had eBGP between these internet facing routers. So from router 3 to router 1 we are eBGP neighbours, and from router 1 to router 2 we are eBGP neighbours. And this was needed so that we could therefore gain a route from router 3 to router 2 and vice versa from router 2 to router 3 through eBGP, so then we could create and configure the tunnel between the two. So now that's done, we have OSPF to implement, and we also have HSRP. So we're going to start off with HSRP, and we're going to go from the Birmingham LAN and work our way upwards. So yeah, let's get into the Birmingham LAN. So first of all, what we need to do is we need to configure some VLANs on this switch. So this is going to be VLAN 10 and VLAN 20. So I'm going to go on the switch now, and first of all, I'm going to give it a host name. So conft and I'm just going to call it hostname and just S1. There we go. So first of all, we're going to go VLAN 10, and I'll just, when I'm doing these, I just like to call it the name and the number. So name 20, or exit off there, and then we're going to go interface FA or G1/0 is VLAN 10. So 1/0, and this is switch port mode access, and then we go switch port access VLAN 10. So it's a member of VLAN 10. And then we've got interface GI 1/1, I believe it is. Yep. And we'll do the exact same. Make it an access port, and then we'll put it into VLAN 20. So we've got exit, and then we'll have a look at our VLANs, and as you can see, we have 1/0 in 10 and 1/1 in VLAN 20. So there's our VLAN set up. So that was nice and easy. And now, because we're going to be using this guy as router 4 as a standby for VLAN 20 and router 5 as a standby for VLAN 10, we're going to have to create a trunk between our access switch and the routers, so that both VLANs can traverse the link. So in case VLAN 10's gateway does go down, it can then go to the VLAN 20 and traverse between that link between switch 1 and router 5, so that you can use router 5 as its gateway. So I'm going to create the trunks between these, the switch and the routers now. So we'll go interface range. I believe we can do a range, so we'll go interface range. Just makes it a lot easier. GI 0/1 to 2, and then we'll go switch port mode switch port trunk encapsulation .1q. So we need to state that the encapsulation method we're using is .1q first. Sorry if you had a black screen there, I'm not too sure what happened. I think the HDMI cable got loose on my laptop to the monitor, but hopefully you guys didn't see that. And then we'll go switch port switch port mode trunk. You can also go switch port trunk allowed, and then you can go VLAN and then just type in your VLANs, but I'm not going to do that just for the sake of this video, but just to show you guys you can do that. So if I go show interface trunk, there we go. You can see now between these 10 and these two links here, and because these are layer 3 switches, remember they're not actually routers, so you can create a trunk between the layer 3 switch and the layer 2 switch. So yeah, there we go, and we've allowed just these VLANs across that link. But just for the sake of this video, I'm just going to allow everything along that link. That's usually used in security for purposes of security, sorry. So one. There we go. So now if we go show interface trunk, we can see that everything is allowed across that trunk. So that is all good, and we're going to go onto our routers now. So, well, our layer 3 switches. So yeah, these haven't been configured at all. So compt, then we go host name, and this one is router 4, I believe. It looks like it. So what we're going to do is we're going to firstly create the VLANs. So VLAN 10, name 10, and then we'll go VLAN 20, name 20, and we'll exit there. And also just show interface, just to show you guys that we're still trunking. It negotiated to use 802.1q, and it negotiated to trunk. It obviously must have been in dynamic auto mode, so it could negotiate that. Otherwise, if you have non-negotiate, you don't negotiate the trunking between the link. But if you have obviously auto or desirable, then you're going to negotiate trunking, and with desirable, you are the one who initiates that negotiation, whereas auto, you wait for the negotiation. But yeah, so there's our VLANs there, and then we're going to go VLAN 10. Oh, sorry, exit interface. Oh, interface VLAN 10, and then we're going to give it an IP address, and this IP address is 192.168.10.1. We'll go 25. Just give it a /24 subnet mask just to make it easy, and there we go. And we'll go interface VLAN 20, IP address, and this is 192.168.20.2, I believe, or 20.1, and then it's /24 also, and we'll just now shut it there. There we go, that's all good. And then our router 5, no configuration on this switch either, or router, layer 3 switch, hostname R5, and then we're going to go same concept, so VLAN 10, name 10, VLAN 20, name 20, and then we'll go VLAN, oops, VLAN 10, oh, I'm having a nightmare, interface VLAN 10, and then IP address is 192.168.10.2, I believe, yep, we'll go .0, and then we'll just no shut that, and then we'll go interface VLAN 20, IP address 192.168.20.2, oops, 255/24. So yep, show IP interface brief, and we should see our VLANs in an up state. In order for the VLANs to be in an up state, an interface either needs to be a part of that VLAN, or an interface can be trunking that VLAN. Otherwise, it's going to be an up down state. So yeah, just make sure that you have either an interface applied to that VLAN or associated with that VLAN, or you have that VLAN being trunked across a link. So then it will be in an up state. So there we go. We have got our two VLANs there. So now I'm going to start off with router 4, and what I'm going to do is we're going to create the HSRP group for router 4. So we're going to go standby, and then what you need to do is, as you can see, you need a group number, or standby 1, we'll create our group number. Sorry, interface VLAN 10, there we go, standby, there we go, group number. And now what we need is, firstly I'm going to do the IP address, so IP and 192.168.10, and this virtual IP is .254, so it needs to be in the same subnet as the interface it's associated with. So with this interface it is VLAN 10. Earlier I completely forgot what I was doing. I just had a brain fart and I tried to do it in global config mode, as you can see there. That's why I got confused that nothing was being recognized. But you do obviously have to do it with the under the interface, as it's going to be your LAN facing interface. So that's why it needs to be within the same subnet as your LAN facing interface, so that they can just communicate. So there we go. And then we go standby 1, and this one I'm going to change the priority of it. Default priority is usually 100, but this one I want for group 1, I want it to be the active, so I'm just going to put 255, and then I'm going to put standby 1, and I'm going to preempt it. So preempting means that if this router 4 goes down, which is the gateway for VLAN 10, if this goes down, router 5, which is the standby, should then come up. So then it should be in the active. But then if my router 4 does actually come up, I want it to take over from router 5 again, so I'm going to use that preempt command so that when it comes up it can take over from router 5. Router 5 will then go back into the standby mode. This is sometimes used, say if you're using sort of like an ADSL as like a backup, but once the primary router comes back up, you don't want to be using that ADSL link anymore, as it's got less bandwidth, etc. So you want to go through the link which has the more bandwidth and faster speeds on that link, I presume. So we're going to preempt on that link there. So that's all good for that one. And then I'm going to create a standby 2, or actually we're going to do this on router 5. So router 5, I'm going to go conft VLAN interface VLAN 10, and then I'm going to go standby 1. So these have to obviously match IP address 192.168.1.254. Oh yeah, there we go. See, as you guys can see there, this isn't even in the this is not a subnet. You get that this is not address within that subnet, so you get that warning. So I'm going to go here and negate that command, and then I'm going to go standby 1 IP, and then it was 192.168.10.254, I believe, and then there we go. And then we'll go standby 1. You can just leave the priority as default, but I'm just going to change it to 250 just because why not. And I'm not going to preempt it on this one because I don't want to preempt on this one. I don't want it to become the primary. So however, on VLAN 20 I do want it to become the primary. So interface VLAN 20, and I'm going to go with standby 2. This is going to be in group 2. I'm just leaving both of these within version 1, just because there's no need for version 2, but you can change to version 2, and this gives you a lot more groups, I believe, that you can create. And you can also have you can change the failover time to milliseconds rather than a few seconds, because the hello timer between the two by default is 3 seconds. So when they're communicating, the two routers, they communicate every 3 seconds. So if it doesn't hear from another router within them 3 seconds, or within the dead timer, I think the dead timer is, I don't know, I think it's 3 and 10, I may be wrong there, but if it doesn't hear within the dead time, then it goes down, and then the standby will then become the active. But you can actually change that into milliseconds with version 2, so if it doesn't hear from the primary router within a few milliseconds, then it will then take over as the primary router. So obviously it's better in terms of faster failover, but within a lab environment, there's no need to change that. So then we'll go IP, and then it's 192.168.20, and then this is going to be the primary for this one. And I'm going to go standby 2 priority 255, and then I'm going to go standby 2 preempt on this guy here, and there we go. Exit there, and then we'll go back onto our router 4, and then I'm going to go standby exit interface VLAN 20, and then go standby 2 IP 68.20.254, and then I'm going to go standby to priority, and I'm just going to put it as 250. There we go. So when we go show standby, so if you go show standby, obviously say if you're in an exam environment and they give you an output from a debug command and it shows this as the MAC address, so AC whatever. AC means you're using version 1. When you're using version 2, it's normally F and then the group number, but with version 1 it is AC and then the group number, as you can see there. So that's what we're using there. And then here's our priority. So this is for group 1. So this is the standby router's priority. And then here's the hello time. Yep, so it is 3 seconds and 10 seconds, sorry. So it was right. And this is our priority. So our priority is 255, and then the standby priority is 250. So there we go. For an easier view of that command, you can just go show standby brief, and then you can just see here. So for VLAN 10 group 1, this is our priority here. We are the primary router and we are the active router, as you can see there, the state. Sorry, this is to preempt, sorry. We are the active router, and the active state is the local router, which is us, and then the standby router is this guy, and that's the virtual IP. For VLAN 20, however, we're in group 2, our priority is 250, we're not preempting in this case. We are currently the standby router, the active router is this guy, the standby router is the local router, and then this is the virtual IP. So there we go. And then if I go on to this guy and console on, we should hopefully be able to ping our gateway. So route 4, let's just see show, or let's just do it from this guy, ping 168.1 or .10, sorry. What's this guy's IP? .10. So let's just see, and there we go, we're able to ping this guy. So this guy can actually ping his gateway. We'll just confirm it from him. .10.254, boom. So there we go, we can ping our gateway. So I'm not too sure how to do a continuous ping on this guy. Ping there's the data size, but I just want to have a load of pings going through. I don't think you can specify it. So ping 192.168.10.254, and then I'll just want to have a load of pings going through. Packet count, there we go. So ping him, then -C, and then we'll just do like 1,000 or 10,000, whatever. Ah, there we go, that works. So as you guys can see, we're currently pinging our gateway, but what would happen if our gateway went down? So let's go into this guy, interface VLAN 10. So as you guys can see, I'm able to do, there we go, detach. So let's get this guy out here. Oh, reconnect. What happened then? So I want to detach, come on. There we go. So as you guys can see there, I'm going to put this in the corner. So this is just like a little experiment for you guys. So we're pinging our default gateway. So we'll just leave that over in the corner just to show you guys that we're pinging him. So we're going route of 4 now, and we're on that VLAN now. So if we go into this VLAN and we go shut down, we shouldn't be hearing from this guy. So we shut it. So we're timing out, timing out, timing out. But if I go into this guy, reconnect, this guy should take over. And there we go, we've gone to the active state in VLAN 10 on router 5. You couldn't see it there because we disconnected from the SSH session, but this guy's now the active, and if you guys can see, we did time out for a little bit, but we're not timing out anymore. There we go. So we timed out for how many seconds? 1, 2, 3, for about five or so packets. But we'll do the exact same again. Watching this guy come back up. So if this guy comes up, he should then become the active. So no shut. Okay, it's come up. It shouldn't even change. And there we go. We had literally one timeout, so you're not going to really notice that. But obviously, when you're using version 2, you can configure that to be literally milliseconds, so you're not even going to notice that one timeout there. But yeah, we're now the active. So yeah, that is a great way to obviously have a greater redundancy, because you have VLAN 10 on both routers, so you can just fail over between the two. So that's a great way to have a greater redundancy between the two routers. I'm not too sure how long I've been rambling on for, but I think I'm going to leave that there, and then we're going to do OSPF within the next video. So the next video should be about 5 minutes to 10 minutes long. We're just going to configure basic OSPF. So yeah, hope you guys have enjoyed the video. If you did, remember to comment, like and subscribe. I'm sorry if some of the commentary wasn't the best. I'm still trying to improve on this, but I hope that these labs are helping you guys out. Obviously I'm not a trained a trained teacher, so if you guys do actually want to get the ins and outs of what's going on within these labs and get full information, I'd recommend going over to watch your CBT nugget videos again whilst going through this lab, maybe, or watch this video then go over your nuggets. Check out David Bumble's video series or CCNA series on Udemy. Chris Bryant also, and also the CCNA official certification guide. Maybe you could read that and then go through this lab here, or or go through this lab and then check out other material that you guys are using. But I do hope that this has hopefully helped you guys out, and I will bring you guys the next video soon. So yeah, thank you, and I'll see you guys later. Bye bye.